Have you ever found yourself in a situation where you need to update a data structure, but you know that other systems are relying on the old format? This is a truly common and often complex challenge in distributed systems, especially when different services need to communicate seamlessly. Managing these changes without causing disruptions is key to stable integrations. Effectively versioning Webhook event payloads primarily involves two key strategies. First, embedding explicit version numbers directly within the payload structure itself. Second, leveraging HTTP content negotiation through dedicated headers. These methods ensure that both event producers and consumers can adapt to evolving data structures gracefully and predictably. This disciplined approach to versioning is absolutely essential because it allows both the sender, or the producer, and the receiver, or the consumer, of Webhook events to understand precisely what data format they are dealing with. Without clear versioning, even a seemingly minor change to a payload could inadvertently introduce a breaking change, disrupting downstream services, leading to unexpected outages, and making debugging efforts significantly more complicated. Think of versioning as maintaining a clear and agreed-upon communication contract between different parts of your software ecosystem, ensuring reliability and mutual understanding. To implement in payload versioning, you would typically include a dedicated field, like a version number such as V1 or V2, directly within your JSON or XML payload. This version field acts as a clear signal, telling the consumer which specific data structure to expect and how to interpret its contents. For instance, a new optional field might appear in V2 that was completely absent in V1, or an existing field's data type might change. When employing HTTP headers for content negotiation, the consumer takes the initiative. It can specify its preferred version in the accept header of its request, perhaps stating application/v2 plus JSON. The Webhook producer then processes this request and responds by sending the appropriate version of the payload in the content type header of its response. This method allows for greater flexibility. It is often highly beneficial to support multiple versions concurrently during a transition period. This allows your consumers ample time to upgrade their integration logic without facing immediate breakage. For non-breaking changes, such as merely adding new optional fields to a payload, you might decide that a full version bump is not required. However, for any breaking changes, like renaming an existing field, altering its data type, or completely removing a field, introducing a new major version is definitely needed to protect your consumers. Always remember to communicate these changes clearly and provide robust deprecation timelines for older versions to give integrators sufficient notice. For truly robust and scalable systems, an advanced technique involves utilizing a schema registry. A schema registry functions as a central, authoritative repository for defining and enforcing the structure and versions of all your event payloads across your entire organization. Tools like Apache Avro or Google Protocol buffers can be seamlessly integrated with these registries. This integration provides strict schema validation, ensuring that all outgoing payloads conform to an agreed-upon structure, and can even facilitate sophisticated schema evolution rules, simplifying forward and backward compatibility. This adds an invaluable extra layer of control and predictability to your event-driven architecture. By thoughtfully implementing these comprehensive versioning strategies, whether through explicit in payload numbers or sophisticated HTTP content negotiation, you are doing much more than just managing data formats. You are actively ensuring that your Webhook consumers can reliably process events, that your entire system remains highly resilient to inevitable changes, and that you foster a trustworthy and easily maintainable ecosystem for all your integrations. This proactive and strategic approach ultimately saves significant development, time, and operational effort in the long run, contributing to overall system health and developer confidence.
If this helps you code smarter, like, subscribe, and stay tuned for more.